This video is on exercise 9C of the differentiation chapter of A-level maths pure 2 textbook. So question 12. The curve C has this equation. The point A on C has x coordinate 3. So let's write here 3. And we need to find the y value. Find an equation of the normal to C at A in the form ax plus by plus c is equal to 0, where a, b, and c are integers. Right. So the very first thing that we can do here is, since we want to find the equation of the normal, we need to have a point. And in this case, we should find the y value. So we substitute 3 into the equation of the curve, and that's y is equal to 4 over 2 minus 4 times 3 squared. So this is 4 over 2 minus 12, which is minus 10 squared, which is 0.04 or 4 over 100. Right. So this is the y coordinate of the point A, and now we should find a gradient, because then we want to find the equation of the normal, so we should have the gradient. We start by differentiating this equation, and so dy by dx is equal to, first of all, let's just rewrite this equation in this form. Y is equal to 4 times 2 minus 4x to the power of minus 2. Because when we want to differentiate this one is easier to deal with. Now when we want to differentiate this, so first of all, this is again chain rule, as almost all the questions of this exercise. So we start by writing down 4, because that's just the factor which is out, and then 4 times, so we write down the power times the derivative of inside. So minus 4x differentiates to minus 4. And now we write down the bracket with its original power minus 1, which we get minus 3. So simplifying this, we get 32 over 2 minus 4x cubed. And now we can find the gradient at point A. So the x coordinate of A is 3. Now we can substitute that into this our derivative. So when x is 3, we have dy by dx equal to 32 divided by 2 minus 4 times 3 cubed, which is 32 divided by, so 2 minus 12 is minus 10, minus 10 cubed is minus 1,000. So now let's keep this, keep the gradient in this form or as a fraction, because later on this will be useful, since we want to have our final answer as integers. Of course, we can convert them into decimals, but sometimes some fractions won't give us some nice decimals, and that's why my preference is always with fractions. So, but be careful, because this is the gradient of the tangent to the line, to the curve of the tangent, but we want to find the normal, so we need to find the gradient of the normal, which is the negative reciprocal of the gradient of the tangent. So gradient of the normal is the negative reciprocal of this, which is 1,000 over 32, which is positive. So now this is our gradient, the gradient of the normal. So now we can, and also we have the point, because point A is 0.04. So now we have a point, and we have the gradient of the normal, and now we can simply find the equation of the normal. So we should use the general form of the equation of a straight line, which is this, where y0 and x0 are our coordinates, the coordinates of the point. So in this case, we have y minus 0. So as I told you, it's better to keep these as fractions. Let's just here use 4 over 100 rather than 0 0.04. Y minus 4 over 100 is equal to 1000 over 32 times x minus x 0. Sorry. Yeah, we should write 3 because our x coordinate is 3. Now let's multiply this equation by the common denominator, because we want to get rid of the denominators, since the question has asked for integers. So we can multiply everything by 3200. So then that gives me, but there should be some simplifying after that. So this is 3200 y minus, so here we will have 4 times 32, so 4 times 32, which is 128, and here is going to be so we have 1000 times 100, which is 100,000, and times x minus 3. Right, so now we should simplify the expression. So y minus 128 is equal to 100,000 x minus 300,000. Now we have 3200y. Now let's take away 100,000 x from both sides, and now let's add 300,000 to both sides, and we get so many large numbers: 299,872. Now the good news is that we can divide all of these terms by 32. So yeah, you can leave your answer in this form because the question hasn't asked us for anything else. So it doesn't really matter to just leave the answer in this awful form. But yeah, you can also divide everything by 32 to get the answer in the simplest form. And if you do so, if you divide each term by 32, you will get this as your final answer of the equation, which is the simplified version of this big mess. So you will get minus 100. So yeah, it depends on which way you rearrange. In this case, you will get 100y minus 3125x, and so sorry, here should have been positive. Yeah, here should have been positive, and then here will be negative if you simplify the negative 9,371 is equal to 0. So yeah, this will be your simplified equation, and this is the one which is not simplified. Yeah, so in this case, I think as I told you, my preference is fractions, but that doesn't mean each time using fractions is the best thing, because I also tried this question with using decimals, and I didn't try using fractions. So now it turned out that decimals was the better choice for this case. Question 13. Find the exact value of the gradient of the curve with equation y is equal to 3 to the x cube at the point with coordinates 1, 3. So let's call this point P, and this is the function we have. And now we want to find the gradient at point P. So now we need to differentiate this as usual. And now here we have this type of differentiation, which in this type, remember that when we have a number to the power of x, so y is equal to a to the x, then what we do is that the derivative is equal to, so we write down the function again, so whatever here we have, we write down the full thing times the natural log of the base, or a, times the derivative of the power. So in this case, the derivative of x is just 1, but we can write that in this way as well. So like d dx of, whatever you have on top. So in this case, let's call that here f of x, which means just any function in your power. So, that's one way of just memorizing in a step. So you have 3 steps. First, write down the full thing again, then times the natural log of the base. So, the first 2 terms are very simple without any differentiation. Only the third one actually needs you to differentiate. So the third term needs you to differentiate. Or you can use the chain rule, and you can consider the power as your, you can call your power, for example, t, and then you can use the chain rule to differentiate this. So now in this case, we are going to use this method, which is quicker in my opinion, but feel free to use the chain rule as an exercise for yourself. So in this case, as I told you, so we can write down the full thing again times the natural log of the base. So the first 2 terms are very simple. We literally haven't done anything, times the derivative of the power. So x cubed differentiates to 3x squared. Now one more step, which is just simplifying a bit. So we get 3x squared ln 3 times 3x cubed to the power of x cubed. Now the question is find the gradient at this point. So now we want to substitute 1 into this, and we will get, so here 3 times 1 squared times ln 3 times 3 to the 1 cube, and we get here 3 ln cubed times 3, which is 9 ln 3, and this is the gradient. Okay, so that's it for this video. Please subscribe for more tutorial videos. Good luck.